All right, last page. These are our two proofs, so these are highly important. Make sure you understand that we have our given idea presented at the beginning of the proof. A geometric proof is going to have 5 parts. Given, what we're trying to prove, a list of statements, reasons supporting those statements, and in a geometric proof, there's always going to be a diagram. All right? Well, where we're going to start is with that given. The measure of angle MOP equals the measure of angle ROP, and they both equal 90 degrees. Also, angle 1 is going to be congruent to angle 4. So even on the diagram, I'm going to kind of make a note. We've said angle 1 and 4 are the same. Well, step 2. Those two look a lot alike. I can switch in between congruence to saying that their measures are equal. That's what the definition of congruence says. If they are the same object, then their measures are equal, and we can start to talk about equations. So, step 3, big deal. This looks like quite a bit different than anything that's been said, so usually I'll look up at the diagram. Angle 1 plus angle 2 equals angle MOP. Well, yeah, if I put 1 and 2 together, that should be angle MOP. They're kind of saying the same thing in the other part of this, that 3 plus 4 better equal ROP. This is the angle addition postulate. All right. And then next, I start to see that moving into step 4, that these two equations look a lot alike. The one difference is instead of angle ROP, it says angle MOP. Well, in step 1, they said that MOP and ROP are the same, so I should be able to make that switch if those are the same. All right, taking this out, we're putting this in. That's a substitution move. And then, all right, we got the 3 plus 4 equals MOP. And next we're saying that 3 plus 4 equals 1 plus 2. Well, this is a really tough one to see. If 3 plus 4 equals MOP, and we also said in step 3 that 1 plus 2 equals MOP, that means I should be able to take 3 plus 4 and put it right here in place of MOP. This is another substitution move. And then step 5, step 6, the only thing that changed is they changed 4 into 1. All right, well, in step 2, if 1 and 4 are the same, we can change 4 into 1. 3 in a row, we are replacing things. So try not to get caught in your head that everything's got to be different. It's not the case. Now I'm giving you a hint here. We're going to use the reflexive property. Look what we're trying to prove. That better be our last statement. We're trying to prove that angle 2 equals angle 3, which we pretty much have there. This angle 1 is in the way. If we could just get rid of that, which we can, use a reflexive step to let everybody know that we're going to subtract it away. 1 proof down, 1 to go. All right, left a blank here for the given, just trying to see if you guys understand the structure. Well, here's our given right here. CD equals 3x minus 12. DE equals 42. And we got CE equals 8x. Well, step 2, we're going to be using the segment addition postulate. Remember, postulate, we're trying to say something very simple that nobody's going to argue about. Segment addition postulate.
At this time, students who ride the bus
it's an announcement. Let's try to ignore that and keep going.
C200 wing may be released.
CD plus DE should equal the whole thing. Well, if CD is 3x minus 12, we could probably start to replace these items with their values that are up on the diagram. For replacing things, that's a substitution move. Now, the rest of this proof is kind of up to us. So we started to think, what would we do next if we were going to solve this algebra problem? I always believe we should combine like terms if we can. Nothing to do on the left side of this equation, but on the right side, we can put negative 12 and 42 together to get 30. That's called combining like terms or simplifying.
In A100, B200, bus riders may be released.
Next, I'm going to move all the x's to one side, but I'm going to go and do a reflexive step just to really slow this idea down. I'm going to announce to everybody we're about to mess with 3x, and then I can take it away on both sides using subtraction. If you didn't want to use a reflexive step, that's actually fine. And then from here, I'm going to get rid of the 5. So I'll do a reflexive step. And we're going to have to use division to get down to x is 6. I would want to make sure. Is that what I was supposed to prove?
Bus riders in B100 and the M wing may be released.
Sorry for the interruption, but we just did both proofs. Good luck on the test.